Okay, I want to show a method that I use for short circuit detection, and it's a little bit unconventional. It's not unpopular. I have heard of old timers doing this, electronics repair guys. In fact, I actually built this circuit into my isolation transformer. So when I'm working on electronics and looking at stuff with a scope, I'm protected. But anyway, out in the field, I also will use this method. And let me just say to the safety police, if you don't like it, don't do it. You know what I'm saying? I'm fine with it. And I'm not recommending anybody else do it, but I work around stuff that's way more dangerous than this every day. And I'm fine with this, and I take the necessary precautions to make it safe for me. So with that out of the way, let me explain the circuit. What I've done here is I've cut an extension cord in half and put alligator clips on it. Yeah, safety police love that one too. Anyways, that is so that we have incoming power here. Let's say that this is a 120 volt control circuit, and I've got a short somewhere and I'm trying to find where it's at. Well, I am going to connect to where it comes in, the incoming power. I'm going to take that power, run it around in here through the bulb filament and back out. So the bulb is in series now. And then my control circuit goes out. I've got a short right here, and then it comes back to neutral. And just to show you how this works, I went ahead and threw something else in the circuit to show that even if there is other things in the circuit, we can still follow the current to find the short. That's the goal with this. Follow the current to find the short. All right, let me power it up. So we've got power now. And I'm not sure if you can see the screen, but I'll read it out as I'm going along. All right, so right at the source, we have 1 amp. Okay, so our short is being current limited by the bulb. The bulb's only allowing 1 amp into the circuit. So I'm wondering, all right, is the short on this little path of the circuit? I clamp around there and I've got 0. Okay, well, it's not going that way. So then I go back here and I clamp here. Is it going this way? Yes, it is going that way because I have my 1 amp of current. And you keep working your way downstream until you clamp around something else and the current is not there. And then you know that that current is going right down here to ground, and then that's it. It's not coming back. So once you get your current, once you limit your current and you get it safely flowing through the circuit, you just use your amp clamp to go along and check the different branches of the circuit and see where it's going. You could maybe check different components and things like that. Now, I will say, you've only got a 100-watt light bulb there. In this case, I got a 300. I use that for, that's what's on my isolation transformer, and that will allow quite a bit of a load before it'll drop it out. Anyways, that's kind of a tangent, but back to what I was saying, because you only have a 100-watt light bulb, keep in mind that if you have a big old motor down here, it's going to appear like a short. All your voltage is going to drop across that light bulb as that motor is trying to turn on. So if you've got some inductive loads and things like that that can appear like shorts but maybe aren't, it might be a good idea to get those out of the circuit. So you have to use your brain with this and know what you're looking at and kind of know what you need to do based on what you already know about the electrical circuit. But this is the basic idea, and like I said, I've used it out in the field. It works extremely well, but Obviously, there are some safety concerns, and you have to know what you're doing. All right, well, I hope that was at least interesting, if not helpful.